as you can see, we have a right angle triangle. This is why you have the 90 degree. Then we have the AC and we have the AB and the BC. The AC stands for the height and the BC, that stands for the base. So we have three things to do. The first thing, we find the area of the shape. And the second, we show that AC equal to root 5. Then the third, that we show that tan angle ACB, that is, this angle will be equal 5 root 3 minus 8. That is the target. So let's start from the area. Area first. Finding the area, we apply the formula for area. Area is equal half base times height. That's the formula for area. So you have the base, root 3 plus 2, and you have the height, 2 root 3 minus 1. So you have to do exactly what the formula says. So it's going to be 1 over 2 times base, which is root 3 plus 2 into bracket height. That is 2 root 3 minus 1. That is how it goes. So you expand the bracket here, everything over 2. It will give us, so we have root 3 times 2 root 3. Root 3 times root 3 will give us 3. Then 3 times 2 will give us 6. So we have 6 here. Root 3 times minus 1. You have minus root 3. 2 times 2 root 3. It will be 2 times 2 give us 4. That is plus 4 root 3. Then 2 times minus 1, you have minus 2. All over 2. So 6 minus 2 is possible. Minus root 3 plus 4 root 3 is also possible. There's 1 here. It's going to be minus 1 plus 4. That will give us 3 root 3. So 6 minus 2. That will give us 4 plus 3 root 3 all over 2. That is root 3. That is plus 4 root 3. You're going to say minus 1 plus 4 gives us the 3 root 3. So we have the area. The area of the shape is 4 plus 3 root 3 over 2. That is area there, done. 4 plus 3 root 3 over 2. So that is how far you can go. So the second target now, that is question B, we want to find the AC. So since the shape is a right angle triangle, so you're looking for the hypotenuse. So let's start that one now. Finding the AC, which is the hypotenuse. So we are going to apply Pythagoras theorem here. So AC, which is the hypotenuse, will always be equal AB, you square it, plus BC when you square it. That is what Pythagoras theorem says. AB. So we have 2 root 3 minus 1. That's a square there. Let us expand it. So our AB, that gives us 2 root 3 minus 1. So when you square it, it means twice. 2 root 3 minus 1. So let's expand it and see what we have from there. So one by one. 2 times 2 will give us 4. Root 3 times root 3 will give us 3. So 4 times 3, that will be 12. Standing by. 2 root 3 times minus 1 will give us minus 2 root 3. Then let minus 1 do the same thing. Minus 1 times 2 root 3 will give us minus 2 root 3. Then minus 1 times minus 1 will give us plus 1. Then let us simplify it further. 12 plus 1 will give us a certain 13. Then minus 2 root 3 minus 2 root 3 will give us minus 4 root 3. So that is how far we can go as far as the AB. So let's put our AB. Let's put the answer here. 13 minus 4 root 3. Then let's do for BC now. BC. BC we have, that is BC square. So we have root 3 plus 2 into root 3 plus 2. That is what it is. So let's expand it. Root 3 times root 3 will give us 3. Root 3 times 2 will give us 2 root 3. Then 2 times root 3 will give us 2 root 3. 2 times 2 will give us a certain 4. So let's merge it together. 3 plus 4 will give us 7. 2 root 3 plus 2 root 3 will give us, that is 4 root 3. So that is what we got. So the BC square gave this. So we're going to put them here one by one and see what we have. So since our AB is 13 minus 4 root 3 plus our BC is 4 root 3. It's 7 plus 4 root 3. That's what BC is. So let us simplify now. So AC square. Let's simplify it now. 13 plus 7 will give us a certain what? A certain 20. Then minus 4 root 3 will remove minus plus 4 root 3. So you have your AC square equal 20. Then take the square root. So AC will now be the square root of 20. Then this is solid. You can break it down into 2. It's going to give us root 4 times root 5. So 4 is a perfect number. The final answer will now give us 2 root 5 as required. So the AC is 2 root 5 as required. That is the proof. Then the last one now is for us to find the angle C. So let's go and get angle C. To get angle C now, so we have the opposite and we have the adjacent. That is tan. So you say tan theta. Tan theta is equal opposite over adjacent. So the opposite is 2 root 3 minus 1 and the adjacent is root 3 plus 2. So you have a surd, a conjugate of surd. So you have to apply the conjugate to solve the problem. So the conjugate of the denominator, root 3 plus 2, is going to be root 3 minus 2. So use the conjugate to multiply the numerator to multiply the denominator. So let's do that now. We're going to have 2 root 3 minus 1 into root 3 minus 2. That's the conjugate, all over root 3 plus 2 into root 3 minus 2. So that is how you apply a conjugate. So now doing that, so we now have to expand and cancel out. So we're going to have 2 root 3 times root 3. Root 3 times root 3 will give us 3. Then 2 times 2 will give us 4. So we have 4 here. 2 root 3 times minus 2. So the 2 multiplied minus 2, you have minus 4. Then the root 3 stands still. The minus 1 will do the same thing. Minus 1 times root 3 will give us minus root 3. Then minus 1 times minus 2 will give us plus 2. Then all over. Root 3 times root 3 will give us 3. Root 3 times minus 2 root 3. Then 2 times root 3 will give us 2 root 3. Then 2 times minus 2 will give us minus 4. So the minus 2 root 3 we cancel out the plus 2 root 3. Then the 4 and the 2 can merge. You have 6. Minus 4 root 3 minus root 3, they both have root 3. So there's a certain one here. It's going to be minus 5 root 3. When the minus 4 is added to the minus 1. Then since the minus 2 root 3 cancel out the plus 2 root 3, then you can evaluate the results. 3 minus 4 will give us a certain minus 1. Then from there, you can now use the minus 1 to divide individual. We're now going to give us 6 over minus 1 will give us minus 6. Minus 5 root 3 over minus 1 will give us plus 5 root 3. So our angle, the angle theta, that is angle C that we are looking for, is actually equal 5 root 3 minus 6. That is it. That is it. That is just it.